video on the Vickers Hardness tester. Now, this is our Vickers Hardness tester. The Vickers tester, like the Brunel tester, is a wide range tester. It tests over the entire spectrum of hardness, whereas the Rockwell testers only test specific ranges. So if you have a sample of mystery material, your best bet is to go to Brunel or Vickers, get a reading off of that, and then use that in turn to send you over to Rockwell, and you can maybe get a little finer reading. But this Vickers test is very, very popular in Europe and in Asia, and it's gaining popularity here in the United States as more and more things are manufactured in China. So a lot of the data that we're seeing now on goods imported from China are all reported with Vickers Hardness. So it's nice to have one here in the lab and be able to use it. This is a superficial tester, so the indentation it makes is actually microscopic. It is still considered a destructive test, but you need a microscope, as you can see here, to test. Now, our control panel is right here in the front. Very simple and requires a moment of explanation. The top light, and you can see delete PRT underneath. That's controlled by this spec button. If you do not press the spec button, the line on the top is the function that's done. If you press spec first, it will use the lower. So this button here that we use a lot, clear F is clear function. Spec clear D clears the diameter. See, they're a little different. And that's probably the hardest thing about using this machine. You can see here it's HV Vickers, dwell time 15 seconds, and the load is set now to 530 newtons, or roughly 500 kilograms. We can adjust the dwell time here up or down. 15 seconds is normal. We can adjust the force up and down. So the softer the material, the less the force. A hard material requires full force. So here we are at full force, 490 newtons. What happens is we have two microscopes. We have a close-in lens and a farther away lens. I am set now on the close-in lens. You always want to use the highest magnification first. And if we look through the eyepiece, you can see the sample in there nice and clear, and I have a picture of that for you. And you get it by looking through the scope and adjusting the wheel until you can see the metal very, very clearly. Once that's done, that means your height's right. Now what you must do is swing the diamond braille into position, and you'll hear that click. When that's done, we clear F to clear all function, and then we can start the test. So now it will preload, and there isn't much to see other than it does that. You'll see the light down on the control panel tells you it's loading. Once it's loaded, it goes to dwell, and it will do its, notice the countdown. T087, it counts down for you. Very exciting. Again, like the Brunel test and the Rockwell test, this is not a speed problem. This is a look at it, and wait and let it finish its job. All right, we heard the beep. The test is performed. We swing. Until we hear the click and get our microscope back in. Look at the picture that I took. I'll look through the eyepiece, and I will see very clearly a diamond shape in there. What we need to do now is measure across the tip of the diamond. So here's, say, my shape. What I do is I bring a set of crosshairs, like the Brunel test. I get it set, and then I swing the other crosshair over, and I measure that height. And then I measure top and bottom. So I measure the two diagonals of the diamond. That's the goal we're shooting for. To do that, there are two knobs. This is our first knob on the left. That sets our 0. So let me look through now. I know you won't see this, but I'll try to get some video for you to show you that. And there's the left all set. Now the right is not. The right's like in the middle of the piece right now. That's controlled with this big knob. And I will now turn that so it just lines up on the left line. So it looks like one line now. And you say, well, why are you doing that? What I'm doing is zeroing it. You see how D1 is now set to 216.38 because I messed with it? Well, that's not right. This is 0. So I'm going to go spec, clear D. It's now set to 0. Now I'll swing the right line to the far right. And forgive me, I got to look through to do this. There's just no way around it. Notice this takes a few minutes to do. This is a microscopic test, so it takes time. I swing through, and I get it just on the other side, and I have my reading. And if I like that reading, I hit the accept key, and notice D2 now becomes visible. So how do I measure up and down? I measured across. Well, it's real simple. Watch this. I take my eyepiece and I swing it 90 degrees. And now I'll line the top up and the bottom. I don't need to re-zero. It's already been done. And it's actually good. It lines right up. So it's 513 and 513. And I accept that. And at that point, I should then have my hardness. I do that how? I press this button again. So as soon as I press it, hardness Vickers 351.7. You can see our indentation. And on the left, you can see the one crosshair. What I'm going to do is, I'm sorry, I got to move it back and adjust it. There it is. I'm going to move the one crosshair to the right. Do you see it going across? There we go. Look at that. And I line it up. This is tricky to do while holding the camera. And I press my button again. And there you go, 477.5. I swing, do the measurement again, and it's all lined up. Press the button again. And this sample is hardness 277.4 HV. Let's take a quick look at the Excel file showing the Vickers Hardness calculator. And you can see the formula here, which involves the sine. And what this comes from is that, remember, now you're measuring the surface area of a pyramid. So all your geometry coming back, it's approximately 1.854. I calculated here. It's actually 1.85436, on and on and on. But you'll see in that last little bit of video, we went from a full load of 490 newtons down to 290.2. And I'll make that change, and you can see it right away pops out the Vickers Hardness at 273, which, like the Brunel, it does have units. It's kilogram per millimeter squared. However, nobody uses the units because HV implies that. But again, you should be able to use this formula and get the answer. So I just wanted to see make sure you knew how to do that. And this D is in fact the average of these two, so it's this 448.31 which you use. But there you go, you're all set now, so go do some Vickers testing.